All right, everybody, this is your video over the four factors that affect a rate of a reaction. Okay, so you can see we have temperature, we have concentration, we have what we call the physical state of the reactants, or sometimes the surface area, and then the presence of a catalyst. Okay, so what we're going to do is there will be four smaller videos, each where we examine those four rates of reaction. Okay, so we're going to start with temperature and then move into concentration and then do surface area and then do a catalyst. And for each of those, minus catalyst, I have a demo that I have prepared for you. Okay, so remember, in a chemical reaction, it follows the rules that are laid out in collision theory, and that the reactants will not react unless all three of these pillars have been met. Okay, and first the reactants must collide. They must collide with the proper orientation and with the proper or the minimum amount of energy, which we call the activation energy if we were looking at it on one of our endothermic or exothermic graphs. Okay, and so those three things have to happen, and by adjusting some factors of a reaction, we can cause that reaction to speed up or slow down. Okay. So, our next topic is the surface area, right? So remember, the surface area is the amount of the surface that is available for reaction, right? So something that is like a solid chunk is going to have a lower surface area than the same kind of substance that has been broken apart into multiple smaller chunks, or powdered or something like that. Okay. So what we're going to do now is we are going to watch a video where I take a solid Alka Seltzer tablet and put that in water, and we're going to compare that to the rate of a powdered or a severely broken up Alka Seltzer tablet, with a much higher surface area, and see how that reaction is different. Okay, so predict, which one will go faster, the solid Alka-Seltzer tablet or the broken up one, and then watch this video, and then we will explain why. Okay.
All right, everybody, in this video, we will be examining the effect that surface area has on the reaction rate of a reaction, okay? So remember, surface area is the amount of surface that is available to be, reacted with by something else, right? So here we've got a whole Alka-Seltzer tablet, okay, which has a lower surface area, right? Because you can only, the water only has an opportunity to dissolve the Alka-Seltzer that's on the outside of the tablet, as opposed to here where we have a crushed up Alka-Seltzer tablet, right, which has significantly more surface area, because it has more surface available to be reacted with. And so what we're going to do now is we are going to place the Alka-Seltzer tablet and the crushed Alka-Seltzer into our water and then hit start. And we want to see which reaction happens fastest, right? So here we go. We're going to go in 3, 2, let me get all the powder done here. 3, 2, 1, go. And, maybe predictably, we can see that the powdered Alka-Seltzer, look at that. It's got like foamy bubbles right there, right? It's reacting so fast that it's actually kind of bringing some of that powder up with it. And so, we see that reaction is still kind of happening, but is about to end. And so as we watch those bubbles start to die away, you can see that the crushed up, the higher surface area reaction has finished faster, while the slower surface area or the lower surface area reaction is still occurring at its usual rate. So there we go. Increased surface area increases the rate of our reaction.
Okay, so you watch that, and now you should see that the powdered Alka-Seltzer tablet reacted significantly faster than the solid one, right? And that is because of the significantly higher surface area. It allowed for more of those particles to be available and open to reaction, right? If we just have a solid Alka-Seltzer tablet, it is only the particles on the outside that are really accessible to the water to get that reaction to start. But if we have it powdered, then there are significantly more particles there that can react, right? So you can see the example here. Here's an example or a picture of low surface area. You can use this picture for your graphic organizer, okay? So low surface area here, you can really only react with the outsides of that large cube, where here we have a higher surface area. There are more faces of that cube to interact with, and so that reaction is going to happen faster. So what I would like you to do is I want you to fill out your surface area graphic organizer, and again, you can use this picture to help you do that. Okay.